Okay, good mornings. In the series of a lecture on operating system, we have started with what exactly is operating system. Then we have tried to cover up various modules which are there in operating system. Maybe we started with the memory management, we started with the process management. In that particular series only, we are going to cover up today, start with the file system management. Okay, how exactly on your system files are being managed. Okay, so, this is what the agenda which we have got for today. We will discuss about file concepts, then what sort of access mechanisms are there for those sort of files, then what sort of a directory structure is there, maybe because what we have got is we got a files. Files are being stored on your systems, but they must be managed. So, once we wanted to manage them, we require some sort of a directory structures there. Then once we have got some file system which we have built on our medias, whatever media I have got, we would have built up some sort of a file system on that. Now, we have to mount that file system. Maybe what we mean by mounting is we would like to connect with the logically with the system there. Then there may be chances that same file may be used by a number of people there, that is what we call as the file sharing. Then some sort of a protection mechanism, so that no unauthorized person is able to access the same file there. So, this is our basic agenda which we have got for the today's talk. Now, as far as a file is concerned, what we mean by a file is nothing but a contiguous logical address space. Maybe I just say in my memory, this particular file will reside from this particular address to this particular address. So, that is what we say is a contiguous logical address space. Maybe physically it may reside at some other places, just like once we were discussing about memory management, we discussed it can be non-contiguous there. Now, same way as far as the logical is concerned, it is a contiguous space which is there, but as far as your physically it is concerned, it may be stored at different places there. Now, question arises, what exactly is there in a file? Now, there are various types of a file, and it can be a data file. Once I say it is a data file, it is nothing but a numeric characters which can be there in that particular file, or it can be characters, or it can be binary files. Maybe all your executable files are nothing but a binary files there, or your program files. Now, how do we differentiate between a data file and a program file? Is data file is just some data which you will be using at a later stage, whereas a program is nothing but a set of instruction which has to be executed. Maybe there is some logical ordering which is there. Let us say I can't say if I am writing a program, okay, this is my first instruction, I can't go to the 10th instruction at the second level only. So, that is how we distinguish between these two types of a files. Data file, maybe it has got certain formats, or it may not be having certain formats there. We will discuss about that also. Then question comes, what sort of file structures are there? It can be none. Obviously, that appears to be very different, there is no structure for a file. What we have got is, it is nothing but a sequence of words or bytes. What we have got is some sort of a text which has been written without any format, without anything, and just it continues. So, that is what we call as some files where there is no structure involved over there, or it can be a simple record structure, that is I have got a lines, or I have got a fixed length records, or I have got a variable length records, or it can be some very complex structures there, maybe your formatted documents. Let us say my paragraph start from this column, ends at this column, there is some sort of formatting which is there for this sort of a text, or relocatable load files. That is, there are certain instructions there, and it has got certain addresses, based on those addresses some sort of a relocation takes place there. Now, we can think about some sort of a mechanism through which we can simulate this sort of a behavior. Now, who decides what sort of files are there? Maybe your operating system does it, or your program does it. Maybe as we said this is your operating system, maybe it is doing it for you, or it is your program which is doing it for me. Now, maybe this needs more explanation, I will just explain it there. Let us say I have got a file, what we see as a a no structure there. Let us say I start writing from this place, this place, this place, this place, and continue like this, maybe a something of the sort. I keep on writing this, so there is no structure involved over there. Maybe in one line I have got 10 characters, on the second line I may be having 3 characters, or there is no break in between, it continues as a text only. So, this is what we call as a file with there is no sequence or a structure which is involved over there, or it can be a simple record structure whereby let us say I have got a line. What I say is my line is let us say this is my line which is there. Okay, we have got a one line which is nothing but it is nothing but number of lines can be there, which we say it is my structure there, or it can be fixed length structures. What do we mean by a fixed length structures are? Let us say I have got a file where I have got a roll number, name, age and qualification. Now, what I do is let us say I keep 3 characters for a roll number. Let us say this is, even if there is no thing, I will say let us say this is 1, roll number 1, then name let us say it has got 20 characters. Let me say this has got 20 characters, this has got 3 characters, this has got 2 characters, and this has got let us say 10 characters. Now, even if my roll number is taking only 1 character, still it will be keeping 3 characters for this. Same way name, let us say my name is Ram. Now, rest of the things will go as a blank, and same way my age is let us say 8 years, 1 character will go as a blank, and qualification let us say I am only 2nd standard. Obviously, I took it once I say age is 8, I can't say it is a BA, right. So, that is the reason why I say okay, it is the 2nd standard only. So, this sort of a records we call it as a fixed length records. Okay, for each of the character we have got a fixed length, and each once my each of the field has got a fixed length, then my whole of this record structure will be of a same size there. Maybe my first record let us say it will be of 35 characters, my second record will also be again be of 35 characters. So, this is what we call as a fixed length records. Now, let us say next can be a variable length record. My variable length structure can be let us say I have got this sort of a structure only, whereby roll number is there, name is there, age is there, qualification is there, but once I am framing this record I am not giving any structure, but I am doing it, I am just going by the separator. Let us say I say roll number 1 comma Ram comma 8 and 2nd. This can be one record. Let us say my other record, let us say my other roll number is 321 Shyam Lal Singh, and he is 28 years and he is MTech. So, this can be the other record which is there. Now, what we have got in this particular case is we have got a record which is of variable length, whereas this record may be having let us say only 20 characters, this may be having 28 characters. Of course, we are not counting it, but this is what we call as a variability. Now, again this sort of a record can be again converted to your fixed length records. Maybe once you write your some of the programs through which I can write all the fields which are separated by a comma, they are to be formatted, and we get a variable length record in this, fixed length record from the variable length records there. So, this is what we call as the file structures. Now, then each of this file, whatever file we have got, that has got certain attributes which are attached to that particular file. One of the first attribute is there will be always a name associated with the file. Now, it depends upon the operating system, what is our name culture or a name structure it has got. Maybe if I go by DOS, maybe it allows you to have a 8 characters name only. If I go to Windows, maybe it gives you bigger names, maybe you can go up to 255 characters also. Or if I go to Unix, it gives me some sort of a privileges whereby my name can start with the alpha numeric character also, or my name can have a special character also. So, like this, each of this operating system has got its own method, own mechanism for naming the files there. Then each of these files they have got a different type. My file as such can be of a different type. It can be a random file, it can be a sequential file, some sort of a type which can be there, or it can be location. Okay, let us say I have got a file, contents are on the hard disk, there must be some pointer which will be pointing to that particular device where exactly the location of that particular file is there, and then the size. Okay, what is the current size of a file? Maybe some of the system they have got a defaults. Okay, by default, let us say some of the system has got by default it will be of 1K file, whereas some files they just go by the number of bytes which are there. You might have seen in some of the system once a file is being stored it says 1024 bytes, maybe you would have stored only 2 characters there. What does it mean? Rest of the thing it is taking it by default as a one block of a 1024, whereas in some of the other operating system it may be giving you a file of 2 bytes. What does it mean? This particular file has got only 2 characters which has been stored over there. Then we have got a protections. Each of the files I would not like to make it as a public files, I would like to give it as a very specific file which is used by a specific set of people. So, that is a protection which we can work out of our file, maybe we will discuss it a later stage. Then we have got time, date and user identification which are there corresponding to a file. When was a file created, on which date it was created, and who, what sort of user identification is there, what sort of user identification can be? It can be just you are a user for a file and this file has been created by one of the persons there. Now, all this information basically what we have got is we have got so much information about the file attributes. We have got a name, type, location, protection, all sort of information is there. Now, this information has to be kept at some place. So, maybe this is where my uses of the directory structure comes. All this information which is there that is kept in the place which we call as the directory structure, and this is where this whole of this information is maintained there. Now, then as we say files are nothing but some sort of a data structure there, it is an abstract data structure which we call. Now, this sort of a data structure they have got some sort of operations which are involved over there. My operation can be, it can be creation of a file, or I have to write into a file, I have to read into a file, or I have to reposition within the file. Maybe you just go for a file seek, you would like to delete some of the things from the file, or you would like to truncate the information from the file there. So, this is some of the things which I can do on this sort of files, but maybe once we have to operate upon this, there is some sort of a system calls which will be there. The moment I say I would like to create a file, there may be some system call through which my system would be, let us say I start with the create, I simply say I am creating a file. What does it mean? I am trying to create a file based on some system call which will be available to me from the system only. My operating system will give me some facility, okay, this is particular system call through which I can create this sort of a file there. So, that is where my system calls comes into the picture. Maybe the moment I say write, there may be some system call through which I am writing into a file there, or same way I am reading. Maybe I have to position my file pointer for both of this read and write. If I have to read a file, what sort of system calls I have to have? Maybe I have to open a file first, that is the first system call through which I have to do it. Then once I have opened the file, then what I do the next, I had to have my file pointed to a particular record. Let us say the moment I open a file initially, what will be the state of my file pointer? It will be on the first record only, and the moment I read the first record, automatically my file pointer will move to the next record there, second record it will move, then afterwards it will move to the third record. How about the write? Now, in case I am there in the write mode, my file pointer will be at the end of the file. I think that is the difference between these two. Okay, my file pointer will be the end of the file, and the moment I say write, it will write at that particular place only, and again my file pointer move to the end of the file there. So, this is then we have got a reposition within the file. I hope some of you might have done some random file processing in case of a C language. We have got fseek, with the help of which we just go to a particular record or a particular record or a particular field there. I just say fseek 10, maybe it will go to the 10th record there, or fseek n plus 1. Okay, whatever is my current position, I add 1 to that, I go to that particular position there, or I can go for some sort of a deletion. That is what we have got as, okay, I have got a file which I would like to delete. Maybe again I look for some system call through which I will be doing it, system call through which I can find out, okay, where is its directory information. Directory information has to be deleted, then whatever are the space it has taken, I had to bring that particular space into the free space there. So, this is maybe I require some sort of a system calls to do it, or I truncate. Now, why these two different things? One is a deletion, another is truncation. Truncation is what I want to do is I would like to keep the information about the file somewhere, but I would like to delete the contents of that particular file. You imagine you have made some information in a file, what exactly I would like to do is I would like to delete the content of that particular file, but as far as my information is concerned about that particular file, what is the name of the file, when it was created, when it is updated, that information I would like to keep. So, this is what we call as a truncation of the file there. Then maybe the basic operation is we have got to open or we have to close. That is, the moment I say open, we search the directory structure on the disk for whatever file I am looking for, let us say fi is the file I am looking for, and move the content into the memory. Now, that depends upon your operating system, okay, how much contents it moves at one time. Maybe it moves one block, it moves one sector. So, that will depend upon the type of operating system which we have got there. And the moment we say close, okay, we move the contents of the entry fi in the memory to the directory structure on the disk. Okay, whatever are the contents which were there, which has not been updated, I move them to the your disk there. Maybe you might have encountered this sort of a thing once you are working on a word processing. The moment you open a file, you make certain editing into that. So, what happens at that particular moment only? There is one set of instruction or set of a data which is there in their memory. Now, you say you want to exit out of the file. What happens? Okay, in case your last update is the same which is the content there, he will simply come out of that. In case there is some updation which has not been updated on your disk, it asks you to save that particular information. This is what is a close. The moment I say exit is nothing but I am saying close. Okay, what I am trying to do is move the content of the entry fi in the memory to the directory structure on the disk. So, this is what I am trying to do the moment I wanted to say I am closing this particular file here. Now, these are the basic operations which are there, maybe your create, write, read, reposition or fseek or delete or truncate, open, close. These are what we call as a basic operation or we call as a primitive operation which I have to perform. Now, with this primitive operation, I can have my own primitives there. Let us say I want like to move or I would like to copy the data. The moment I had to copy the data, what are the operation involved there? we have to create a file, right. Then we have to read the contents from the one file and write the content to the other file. So, basically what we are doing is we are taking combination of a 3 file operation and making a one call through which all the 3 can be operated upon. So, you must be very clear about this thing, okay, these are not the only operation which are possible, it is a combination of these operations which are again possible through which I can do lot of things there. Now, then these are the some of the file types which can be there. One of them is let us say it is a executable files, maybe all your exes, your coms, your bin, or there is none. Now, what is the operating system where you do not have got any extension for the executable files? Oh yes, Linux or Unix. These are the operating system where you do not have got a extension there. It is a none. You do not have got an extension for the executable file, or we have got a object files obj or O. Some of the operating system they take it as a obj file, or some of them take it as a O files, or it is a source code, maybe your C, CC or Java or Pascal assembler, all these are nothing but the extension for the source codes, or your batch files, your BAT or shell commands, they are nothing but your batch files there, or your text documents, maybe your TXT or the documents there. So, all these are nothing but the text documents which are there, or you can have a word processing files, maybe doc, this is a very famous extension once we have got a word files in case of a Windows, or it can be some library files, maybe your lib, maybe your A or DLL files. What is the DLL files? Dynamic link libraries. Okay, these are some of the files which are available in case of a Windows environment, or it is some sort of a print or a preview file, maybe archive files, zip files or tar files. They are basically some files where some information would have been kept in a compressed forms or in some other forms, or it can be some multimedia files. What is a multimedia files? Okay, not only computer can work on a text itself, it can work in some of the other media, maybe it is a audio, it is a video, maybe I have got a signal files or wave files which I got. So, this is what we got a MPEG, MOV or some sort of this sort of file. So, basically these are some of the types of file which my operating system has to support. Now, how does your operating system identifies what is the uses of this particular file? Maybe some of the operating system they identify the uses of file with the extensions. Let us say the moment there is extension DOC, a operating system by default understand this is a word file, right, and the moment there is a file which is from the access, there will be some x files are there, those are Excel file, or some database file maybe .db, or in case it is a source file, it is with the C or a pass or a CC. So, this is how your operating system identifies, okay, this is the file which is there, and some of the operating system look for a file as a executable files also, maybe exe. Let us say I rename a file which I created as a exe file. Do you feel your program will be executed? No, it will not be executed, because by default your operating system tries to understand a file with the help of the extension which has been defined for this. Maybe in case of a Linux or a Unix, what happens is if I do not have got any extension, that is taken as a executable files. So, this is the uses of your extension, and this is the naming culture which can be there for a files. Now, then once we have got a various types of a files, as I said there may be a number of types of files which are there, there may be some sort of access methods which are associated with each of these files. Now, one of the file system which we have got is we call them as the sequential access files. Sequential access is the records are one after the other records. Maybe what you are doing is we all the time we are saying read next, that is every time I am reading the next record which is possible in this particular case, or write next. I can't say in this sort of sequential access read 10th then read 20th, because this sort of a sequential access is like this only, I have to read the record one after the other there. Or I can say reset. What is the reset? I am going to the in the first record there. Then next type of files we have got is direct access files. Direct access is it does not go in a sequence. What I say is, let us say I wanted to read the first record first, then 10th record, then 12th record, then 8th record, then again come to the third record. So, this is what we call as a relative access or a direct access. I say read n. What does this read n means? You read the nth record, or I say write n. I am writing the nth record, or I can say the position to n. That is what I am doing is I would like to position my file pointer to the nth block or a nth record, and then I say read next or write next. What I am doing in this particular case is I am trying to access this as a sequential fashion there. This particular files I am trying to access in a sequential fashion, or I just say rewrite n. What does the rewrite means? Whatever are the contents which has been written at the nth block or nth record, I rewrite them with the new informations there. Yeah, you update that particular information there. So, this is what we call as the access mechanism as far as your files are concerned. Now, this is how my sequential access works. Let us say this is my current position which is there for a particular file. Now, from this particular file I can move in this direction to read various records there. I can read or I can write up to this particular end. Now, maybe where is this particular end? In case I am having a file for the reading. I hope some of you must be have used the end of file pointers in your programming languages. EOF. Okay, we usually have a EOF. What is the EOF says? Okay, I am reached to the end of the file. Beyond this, there is no data which I can read over there. Whereas, in case of a write, all the time my pointer is at the end of the file. The moment I wanted to write, my pointer automatically will move to the next record there. So, this is what we can do in case of a sequential access files, and the moment I say rebind, that is I am trying to take my file pointer to the beginning of the file there. Now, I can simulate a sequential access on a direct access. What I say is, let us say I say reset. What does that reset means? I am taking my file pointer which is CP to the 0th record there, and the moment I say read next, what I am doing is I am reading a record and incrementing my pointer there. Whatever is my file pointer, I am incrementing them with the 1 value there. Or I say write next, I am writing this point write to this particular pointer and then add 1 to the pointer there. So, this CP is nothing but your file pointer. So, this is what we can say, okay, whatever is my sequential access, I can simulate it on the direct access there. So, this is what we call as a index or a relative files. Okay, we have got some sort of indexes there, maybe we will talk about this at some stage, and this is the contents. Okay, this is nothing but the contents which are there in this particular system there, and this is the address there. So, how can I correlate? Let us say you can say this is my sector, I have given address house number to each of the houses. The moment I had to look for a person, I look for the house number first. The moment I get the house number, then I get into that particular house, get the information over there.
Indirect address.
Yes, the direct is a indirect or a index address is there. Just like your books, on the book you have got a initial page which you call as the index page. The moment you look into the index, you find it, okay, 5th chapter I am looking for, then the page number is there. You look for that particular page number and go straight away go to that particular page number. This is what we are doing. Okay, we have got some addresses here, and this is the numbers where exactly this particular record is. Let us say I am looking at a Smith, let us say it is the 25th record. So, what I am doing is I am straight away going to the 25th record here. So, this is what we call as the relative files or the index files here. Now, what is the criteria for file organization? Why should I choose one file organization, why not the other file organization? Now, what we have to have is economy of a storage, that is the maximum thing which we have to have. We should be having the minimum redundancy in the data there, that is the first thing. Or your redundancy can be used for a speed access such as the index, because my index can have a same values there, same names, then we have got a chaining there. Then simply maintenance and the reliability. It is not that I have stored the record, once I am trying to access it, I may be having a lot of operations which I have to perform before I am able to access this sort of a record. Or reliability, what sort of a reliability is there for a particular file. Let us say you make indexes, suddenly you lose your index files. So, what will happen to your files? We can't get that sort of information, because what has happened is, because the moment I lose my indexes, a whole of my file will go. So, that can be some sort of unreliability into this. Maybe a simple maintenance, if I have got a sequential file, it is very easy to maintain. I copy it on a tape, keep it for as many times as I wanted to have. Now, these are some of the file organizations which are there. First we call as the pie. Now, what we do in case of a pie organization is data is collected in the order they arrive. Whenever a data comes, I put it in the file there, and this is for a mass data and save it. Whatever data comes to you, you accumulate it, save it, and maybe at a later stage you can give some organization to it. And again, record may have a different fields and no structure is there, and if I have to look for a record, I have to go for an exhaustive search, because neither I am having a primary key nor secondary key nor any key, I am just putting it as text information. The moment I have to look for the text, I will be looking for in the whole things there. Let us say in case this sort of a organization, if I have to look for a particular keyword, I give the keyword, then the file starts looking into the keyword for the entire file. So, this is what we call as a pie organization. This is how it look like. It has got a variable length records, various set of fields, and there is chronological order which is there, we call it as a pie files. So, this is any of these records can be there in this sort of a structure there. This is structure we call as the pie files. Now, then next we have got a sequential files. Now, my sequential files, they have got a fixed formats used for the records, and all records are of the same length. Whatever records are there, they are of the same length, and all fields the same, maybe order and the length is same. If I got a name as first field, in all the records I will be having name as my first field there. If I got a age as the second field, I will be having age for all these things. If I kept 20 characters for the name, all these names will have a 20 characters only. No name can be 25 characters, no name can be, even if it is a lesser character, still I will be leaving that sort of a space is there. And field name and the length are the attributes of the files here. These are some of the attributes which are attached with the file, length and the field names. Now, one field is the key field. Out of all the fields I have got, we usually keep one of the fields as a key field. Maybe in case there is no key field, your record number acts as a key field there. Now, what is the use of this key field? It uniquely identifies the records, and records are stored in a key sequence. Maybe I can have a sequence of a roll number. If no sequence is there, then what I am doing is I may be having the sequence of the records. So, this is what we call as a sequential file organization, and new records are placed in a log file or a transaction file, and we perform a batch update. Now, how do we merge this sort of a files? Let us say how we work on this sort of files is, let us say I have got this file roll number and name. Let us say this is my master file which is there, or one of the sequential file which is there, and there is a physics marks there, and there chemistry marks there. Let us say this is the structure which we have got for this particular file. Now, there is another file. Now, this file has got information, let us say it has got information about roll number name, roll number 1, 25 Ram, roll number 2 Shyam, roll number 3 Mohan. Let us say these are some other information there. Now, I had to update this information, adding physics marks and adding chemistry marks. Maybe it is available to me at some other place. Let us say there is another file there where I have got this roll number and physics, maybe roll number 1 25, roll number 2 30, roll number 3 45. Let us say these are some of the marks which are there. What I do is, once I have to update, I do not update it as a single one, but what I do is I keep this information in the some log, some file which is to be through which I have to update it, and I just compare. Let us say this roll number gets compared with this. If they are same, then this particular field is replaced here, and same way once this is compared with this, and this fields get replaced here, and then this gets compared here, and this gets replaced here.
So, roll number becomes the key field.
Roll number becomes a key field, and all this information gets replaced over here. So, this sort of organization we call as sequential organization. As far as updation is in this case is concerned, we go for a log file based updation, whereby we merge two files into a single updated file there. Maybe the moment chemistry marks comes, maybe I have got a roll number and chemistry marks, and I can update this information over here from this particular file here. So, this is what we call as a file updations in case of a sequential files. I hope this thing is clear. Maybe you can try to attempt to write this sort of a programs, whatever language you are comfortable with, try to write some of these codes. Now, this is how my sequential file look like. It has got a fixed length records, and it has got a fixed set of fields in that particular order, and they are based on some sort of a keys there. Now, this can be your roll number, name, qualification, and your age. So, then it becomes some sort of a structure which we have defined in this particular file here. Now, next we have got is a index file organization. We call them as the index sequential file. Now, what is the uses of this index? Now, index provides a lookup capability to quickly reach to the vicinity of the desired record. That is the uses of this particular indexing. okay, whatever file I have got, whatever information I have got, I keep an index of that. What is the use of index? It gives me the straightaway accessibility to my record there. Now, it contains key field and the pointer to the main file. Okay, whatever is my main file, it keeps a pointer to that particular file there. As I gave you the example of a books, you have got a first index table. Now, the moment I say my first chapter is, let us say first chapter is laws of motion, it is on the page number 20. What is 20? 20 is the basically index which has been defined for this particular record there, or your teacher as such maintains the information about a student's information on a particular pages. Let us say he writes all the names, then their performance is write on some of the pages. So, this page number becomes a index to that particular file there. Now, what we do is index is search to find highest key values equal to the preceding or the desired key value. Okay, whatever is my key value corresponding to that, I look for the value there. Now, why I am saying highest value? Because maybe I am looking for a record which is not there. I can't keep on looking in all my indexes. I keep on looking, okay, this is between this particular index and this particular index, my index should lie. Just like your binary search, you usually say this particular number is not there. How do you find out? You just compare with the two numbers. In case it is available there, fine, otherwise my number does not exist there. And search continues in the main file at the location indicated by the pointer. Whatever pointer is there, my search continues up to that. Let us say where exactly I should use this sort of file organizations. Maybe I got 1 million records. If let us say there are 50,000 accesses which are required for this particular file, will my operating system allow me to think of a sequential or random access or a index access for this? Because no, it is just like you have got a payroll example. What you have to do is you have got a payroll which you have to process for all the employees. You will never think of a file organization which is a index organization in this case, because obviously I have to process all the employees. But if I got only queries there on this particular file, maybe then in that case I am looking for the indexes. I hope you can distinguish between these two. One is if I have got access where I have got a 90% access of the whole file, then I do not require to be accessed in a index weight. But the moment I have got a file where my access is only, let us say 10% of access is there, then our indexes are useful, because indexes has got a overhead. What is the overhead? Extra memory which I require for having those sort of indexes there. So, this is how maybe in case you think about the 100 accesses, it will be fast, it will give you the value for the money, otherwise it will not give you the cost benefit analysis vis-a-vis your files is concerned. Now, how this sort of index sequential files are made, how my operating system does this thing over there. Now, let us see what says new records are added to a overflow file. What happens is, let us say I define certain areas, okay, this is the area where my records will be there. The moment my records cannot fit over there, what I do is I make a overflow area. I try to put my records into the overflow area. The moment I look for a record, I look for the indexes. At the index page, if my record is not there, I look into the overflow area. Either it will be there in the indexed area or it will be available in the overflow areas. And the overflow is merged with the main during the batch updates. The moment I re-index, I hope some of you might have worked in DBase environments, right. Usually what happens is, one is automatic indexing, other is some of the times, maybe early time what we used to work, we have to go for re-index. What does a re-index means? reindexing is, let us say whatever records I have kept in the overflow area, I would like to put it in the main area there. Because what we do is we just allocate, okay, this is the first record, I allocate this much space to this, second record I allocate this particular space based on the indexes. The moment my index value, I have got an index, I have got a particular area there. In case my area is full with the record, I go to the overflow area. But the moment I say reindex, whatever records are there in the overflow area, I increase the size of the main area and put it there.
It is similar to the defragmentation.
Yes, it is same as defragmentation. So, this is how my look like. Let us say this is my index levels. Now, this is my main file and this is my overflow file. Now, initially what happens is, the moment I had to write, I write the index here and come to this particular main file and write the file over here. But if in case my space is not there in the main file, I write it to this particular overflow area. Same is true with the read. Let us say my index points out to me, okay, my record is in this particular main file. If it is not main file, I look into the overflow area and find out whether my record can be here in this particular case or not. So, this is what we call as a index sequential files, or it can have a multiple indexes for the different key fields also. That is another very interesting characteristics. I hope you might have used this feature at some stage or other. You index your file based on a name and age, or you index your file based on age or marks. What does it mean? I am having a multiple indexes for the same file there. Now, my operating system has to maintain this sort of indexes. Okay, how this sort of indexes can be maintained once I got a multiple files, once I got a multiple keys based on which my indexing can take place, or it can contain an exhaustive index that contains one entry for every record in the main file, or it can contain a partial index. So, this is the way you can think about indexing your files. It can be multiple indexes, it can be a single index for a file, or it can be a partial index for a file there. Maybe I take half of the field out of the record. I say, okay, I am saying out of the name, I just take 3 characters. So, that gives you the partial indexing. So, this is how my index file will look like. Maybe I have got an exhaustive index or some partial indexes, and based on this my file organization will be organized. Basically, what I am doing is I am looking from the information from my primary file area which is available to me. Now, another file organization is a direct or a hash files. What is the hash files? That is, what we do is, instead of indexes, I have a function through which I make the hash value. I hope in data structure you might have gone through these hash values. What happens in this case is, let me explain. Okay, let me say I got a key value. Now, I apply some hash function to this and I get a hash value. Now, I try to organize my record based on this particular hash value there. Now, let us say my key value is 25 and my h of k is nothing but k modulo 13 plus 1. What does it mean? Okay, whatever is my key value which is there, I will take its modulo with the 13th and add 1 to this. What I am trying to do? I am trying to generate the unique hash values Now, this is what I am trying to do. I am just trying to generate some sort of a unique hash values corresponding to this particular thing there. Let us say as I said my value is 25, the moment I say h of 25, what is the value it gives? It will give you no k modulo 13, 13 is to 26, it will give you 12, 12 plus 1, it will give you 13. So, my hash value which has come out to be there is 13th. So, my record, let us say I have defined some sort of a mechanism there. Maybe 13th is there. Now, the moment my value has come out with 13th, I go to this 13th bucket or whatever sector I have got and put this record here. Let us say some space is here where I put this particular record. So, this is how my direct file organizations are there, which my operating system has to support. So, this is what is expected out of my operating system, it has to support this sort of a thing. The moment my hash value comes out with 13, it has to look for in this particular area there. Now, it can be there can be two records which has got the same hash values, then maybe both of the records has been stored at this particular place only in a sequential fashion. I go to my hash value, look for my hash value, then I look for maybe in the sequential fashion there. So, this is what we call as the hash values access, in which case we try to look for a record in a hash manner. And the moment I had to, this is how I write, the moment I had to read, again I take my key value and find its hash value and look for the record where exactly this record would have been stored there. I hope this thing is clear. Maybe there are so many functions related like this only, maybe k modulo 13, k modulo 256, like this. What is your basic idea in this sort of things is, you would like to take as many independent, as many unique values, hash value which it can give you there. Now, in this direct or a hash file, we directly access a block at a known address. This is the what I had to explain to you, and my key field required for each record. Why I require a key field for each record? Because it is based on the key field I will finding out the access there. So, this is what is the analysis for the performance of various file organizations. In case my file methods are this, these are some of the attributes, maybe variable length, fixed length, equal or a greater, or a single record, subset or a exhaustive. That is in case of a space. In case my file is a pi file, my variable records, they have got the excellent and well suited for this sort of purposes. If I got a variable length records, then it is a more suitable for the pi file, but it is a good for the fixed size, because my pi file is not meant for a good size there. And in case of a sequential, it does not have got a, it is a f not reasonable for this sort of a purpose is there, because obviously my sequential file are nothing but a fixed files there. And same way for each one of them, once you have to update or once you have to retrieve. So, this is some sort of analysis which has been done for each of these files there. These are some of the parameters which have been chosen. A is excellent, well suited for this particular purpose, and this B is good, C is adequate, D requires some extra efforts, E is possible with extreme efforts, and F is not reasonable for this sort of a purpose is there. Now, once you have to use your files, maybe this is one of the characteristics, one of the parameters defined by operating systems. Okay, once I have to access a file, I can use this sort of a mechanism for this. Now, how does my file system organization look like? I can partition one of the disk as two logical partitions. One is this file, another is this files. Most of you must be doing it. Let us say you have got a hard disk in your drives. One is you just give it only one partition. You just define whole of this hard disk as a single partition there. You name it as C, and all your accesses are with the help of this sort of a C partition, or you break them into two partitions. This is what we are having this sort of file organization, whereby one partition just keeps Windows, other partition keeps all the information about all the files which I would like to create. What is the advantage of this sort of a partitioning file system organization? Okay, in case my window crashes, then at least my data will be safe in this particular scenario. Or there is another type of partitions. Okay, I have got number of a disk there. Logically, I can club them into a single partition. Let us say I got two physical hard disks on my system, but I can just club them into a one partition there. That is, I got a C partition. C partition is collection of two hard disks there. So, this is how we say is a file organization which can have. I can have one hard disk partitioned into two hard disks there logically, or two hard disks partitioned into single partition there, or one hard disk partitioned into single partition there. So, this is what we call as some type of the file system organization which I can have in this sort of a scenario there. Once you have got a single partition, now what advantage is, in case I have got a mass storages which I have to have, my file is too big. Let us say I got two hard disks, each of only let us say each hard disk of 18 GB. I am expecting my file to be of 25 GB. What will I do? I can't store it on a file. What I do is I combine these two hard disks logically into one hard disk and then store this information. So, that can be the advantage in case I do this sort of a scenario there.
It is not partition, but combination.
It is a combination. You right in saying it is a, you are trying physically there are two hard disks, but logically you are combining them into a single hard disk. So, that my access mechanism is there on the same system there. So, this is what we have done in this particular session. Okay, we have tried to give you various file concepts. Okay, what exactly is a file? As I said, it is nothing but a collection of information, collection of data in terms of either it is a numeric or it is some sort of instruction which can be there. Then we have discussed about the various types of files which are there. Maybe you have got a sequential file, you have got an index sequential file, you have got a random files. Then we have got access methods for this particular files. Maybe in case of a sequential file, I am just accessing one record after the other, or in case I have a random file, I can be accessing first record, then 10th record, then third record, then the fourth record, and we discussed why do we need this sort of files. We have gone for a comparison whereby why we need all this sort of files. Maybe any questions you have got?